what is shear force? Suppose that one force is acting here at the end on this member, and this will try to bend. This will try to bend this object like this. This is trying to bend this object in downward direction. There is a force F, and the member is having certain length, and it is trying to oppose the deflection. Okay, so this type of thing we called it as a shear force, which is acting in perpendicular direction. So this is a shear force. Now after that, there is a moment. Moment is a simple moment. Moment is a simple moment. If your certain object like this, some force is acting on this object, whether this force is trying to bend it or not, that doesn't matter here. Only a simple force is acting here at certain distance, which is equal to your suppose that this distance is d, small d. Then this F multiplied by small d, F multiplied by small d will be your moment here. F multiplied by small d. Okay. Shear force will be your capital F. This is nothing but the shear force. Okay. And what is the bending moment here? Bending moment is nothing but the moment created in order to bend the object, in order to create the support reaction, right? We know the Newton's third law of motion, that is, to every action there is equal and opposite reaction. Okay, so this type of force is creating certain action here, so therefore this object will react to this force, and this is in clockwise direction. Okay, this will create a clockwise moment, and to counter this, anti-clockwise moment is generated as a part of the reaction. You can see here, this force is causing the clockwise moment here, and to counter this object is creating anti-clockwise reaction because of its stiffness, because of its rigidity. It is creating the anti-clockwise moment. Okay, so that moment is nothing but the bending moment, which will try to deform the object, and it will result into the reaction. Okay, simply a force multiplied by distance will give you the simple moment, but bending moment is reaction to that moment. So this is the difference between these two. Okay, so I hope that you got clear this point. Okay, now after that, we were having one numerical in our previous lecture, and that numerical was regarding finding out the moment of couple. Now what is couple? Couple also we have seen in our previous lecture. Couple is a system of forces. There are two forces which act in. Suppose that this object is there. Now on this object, Suppose that this type of object is there. This type of shaft or cylinder is there. Now here, two forces are acting. Suppose that these two forces are acting. One is acting downward and one is acting upward. So for couple, we have seen the 5 characteristics of couple in our previous lecture. Okay. So let's suppose that the distance between these two forces is given, and that distance will be equal to the 1.5 meter. This is the numerical that we have to continue from our last lecture. Okay. Now the quantity, that is the magnitude of force is given, that is 40 Newton, and this is the 40 Newton. So two forces having equal magnitude acting in opposite direction will form a couple. Okay. Now how this couple is formed here? What will be the direction of this couple? As it is acting anti-clockwise, you can see here, this is acting in anti-clockwise direction. This will act in, this will create a rotating effect here, and this is acting in anti-clockwise. This is acting in anti-clockwise direction. Okay, it's having certain direction along its center. Okay, so it will create a rotating effect. Now in that numerical, we were asked to find the effect of this moment at the various location. That will be proved the our fourth characteristic, that moment at any point remains constant, or it will also prove the law of transmissibility, that moment can be transferred at any location. It will produce the same effect on the body. In simple language, we can say that the value of couple, that is the moment by the couple, will remain constant all over this shaft. Okay, so this is the main thing or main characteristic of the couple. So therefore now we will provide the nomenclature to this. Points A, B, then C, and last one is D. Okay. Now after that, the distances are given here. From point B to C, the distance is 2 meter, and from C to D, the distance is 2.5 meter. Okay. Now, what we have to find, the effect of this moment, couple moment at the point A, B, C, and D. At all the points, we have to find its effect, and we have to prove that the value of couple moment at any point remains same. What will be the value of this moment now? We can calculate this. The value will be, according to its definition, moment of couple is equal to moment of couple is equal to 40 multiplied by 1.5. That is one of the force multiplied by the distance between these two forces. This is the definition of moment of couple. So therefore 40 multiplied by 1.5 meter will be the value of moment of couple, and its unit will be Newton meter, force multiplied by distance. Okay. So therefore, this is the exact value of moment acting along the section A to B. Okay. Now, we have to calculate the moment of forces about point A. That is moment of forces at A, at point A. We can say like this. Okay. Now, if you want to find the moment at point A, then now this is a critical part here. So all student, I request all student to keep attention here. Okay, we have to find the moment of forces at point A. So therefore, first force is 40 Newton, which is acting downward at the point A. First force is acting at the point A, which is 40 Newton, which is in downward direction. Okay. So that value will be 0, because what is the definition of moment that we have seen previously? Definition of moment here is force multiplied by distance. You can see here, right? Force multiplied by distance is the definition of moment. Now here, force is 40 Newton multiplied by distance from point A will be 0, right? Force multiplied by distance from point A will be 0 for this first force. So therefore 40 multiplied by 0, 40 multiplied by 0 will be equal to 0. Okay. And the next force acting here on this shaft is again second 40 Newton force, which is acting in upward direction. First force is in downward direction, second force is in upward direction. So this 40 Newton multiplied by its distance. Remember the definition, force multiplied by distance. Okay. So again, this 40 Newton force multiplied by 1.5 distance. Okay. But now this force is in anti-clockwise direction. So therefore we will take it as a positive. Okay. So the sign convention for the moment is anti-clockwise, we are assuming positive. Okay. And clockwise as negative. Okay. This thing we have also seen in our previous lecture. Okay. This is the sign convention for our moment. This is the sign convention for our moment. This is the sign convention. Okay. And what is the sign convention for bending moment? For bending moment, this anti-clockwise is positive and clockwise is negative. Okay. But bending moment, we follow the another sign convention. Okay. That is different. That is the sagging and hogging. This sign convention we follow normally for the bending moment. Okay. So your sagging will be positive and hogging will be negative. Okay. Now, what is the exact meaning of this? If your force is acting on beam like this, Suppose that this beam is here and this beam is here. Okay, beam means it is a section. Okay, and suppose that this force is acting like this, so it will create a positive bending moment. And suppose that this force is acting from downward to upward, it will create a hogging moment. Okay, so this we take it as a positive, this we take it as a negative. Okay, but this is for the bending moment, remember. This is for the bending moment. Okay, this is for bending moment only, remember this thing. This is for bending moment only. Okay, not for the moment. For moment we follow the simple sign convention, that is anti-clockwise positive and clockwise negative. This sign convention we follow. Okay, now let's move towards our numerical again. That moment of forces at point A is equal to 40 multiplied